Okay, so now we are officially almost finishing up Unit 3. If you can do this review, no problem. You should not have an issue on the exam, but you have to watch me do the review. You have to try to do the review by yourself. All right, so first thing, a molecular compound is when a blank and a blank bond. Molecular means non-metal and a non-metal, so two non-metals. You have to be able to look at the periodic table and identify where my nonmetals are so that you can determine if it's molecular or ionic. So the second part is asking you to highlight all the nonmetals on the periodic table. Well, I know that anything from here to here, and to here, and then to here, and then sometimes this one is considered a nonmetal. So any of these are all nonmetals. So if you have something that is bonded this and anything else, then it is going to be ionic because nonmetal and metal. But if you have things that are only in here bonded to each other, then it is nonmetal and nonmetal, and it would be a molecular compound. All right, easy enough. Next, name the following compounds. So I see that this is phosphorus and this is oxygen. So phosphorus and oxygen, these are two nonmetals. So this is a molecular compound, and I am going to name it with the prefixes. Remember, mono, di, tri, tetra, those prefixes. So the first element has a 3, that means I have to use tri, so tri-phosphate. And the second element has 6, and that is hexoxide. Keep in mind, I am using my prefixes, and I'm also ending the nonmetal, the second element in ide, IDE. Next one, I have 1 atom of nitrogen, but I'm not going to use a mono nitrogen because if it's the first element, and it only has 1 atom, then I only need to just write the name of the element. So nitrogen, and then I have 3 hydrogens, so that's trihydride, ending with IDE. Next one, oh, and nitrogen and hydrogen are both nonmetals. Ooh, look at that, I forgot to highlight hydrogen. Hydrogen is also a nonmetal. Okay, next, CCl4. So carbon and chlorine. Carbon is right here, chlorine is right here, both are nonmetals. So this is again going to be a molecular compound, and I'm going to use, sorry, cat here, my molecular compound naming prefixes. So I have 1 of carbon, but I'm not going to say monocarbon because it's my first element, so it's just carbon. And I have 4 chlorines, so that's tetra chloride, IDE. And that's that. So be able to name molecular compounds using this prefixes. All right, next, write the formula for when Mg bonds with F. Okay, so Mg, magnesium, is right here. It is in group 2, and I know that this group has a 2 positive ions all the way down. So I know that my magnesium is going to be a 2 positive ion, and my fluorine is in group 7A or group 17, and I know that all of this group, well, most of it, has a -1 charge. So I know that my fluorine is going to have a -1 charge. I have to balance out these charges. So I have a 2 positive and a -1. So I'm going to need another negative charge to balance out this positive. So I'm going to draw another fluorine ion. And now I have it balanced. 2 positive, -1, -2 negative. 2 positive and 2 negative cancel out to 0. So my final formula is going to be Mg, and I'm going to need 2 fluorine ions. Next one, lithium bonds with F. So lithium is in group 1. I know that things right here are going to have a +1 charge. All of these are going to have a +1 ion. So lithium, let me draw a line right here. Lithium has a +1 charge. Fluorine, we already discussed, is in group 7A, so it has a -1 charge always. And now I see that I have a +1 and I have a -1. +1, -1 cancel out, so I don't need to add any more atoms. I am already balanced, so I only need one of each. Next, barium bonds with fluorine. So barium is right here. It is in group 2, so it also has a 2 positive charge. So barium has a 2 positive charge, just like magnesium. Remember, they're both in this 2+ group. And F, again, has a -1 charge. So I need to balance out this 2 positive charge with a 2 negative charge, but I only have a -1 right now. So I'm going to need 2 ions of fluorine. So now I have a total of a 2+ charge here and a -2 charge here. That balances out. So my final formula is going to be barium, one of it, and then 2 fluorines. If you notice, these two have a very similar ratio. You need 2 fluorine atoms in each one, and that is because both barium and magnesium are found in group 2. So that means that they will have similar ratios. All right, next one. Are the following compounds ionic or covalent? So I know that ionic is going to mean a metal and a non-metal. And I know that covalent is the same as molecular, which means non-metal and non-metal. So even though both of these are like, what? I've never seen these before. These are so long. Just go into each element and see if it's a metal or a non-metal. So carbon, let's find it. I'm going to use a different color here. Carbon is right here. That's a non-metal. Hydrogen, the next one, is right here. That's a non-metal. And oxygen is right here. That's also a non-metal. So I only have non-metals in this compound. So non-metal and non-metals is a molecular, or also known as covalent bond, covalent compound. Next one. I already know that carbon and hydrogen are both non-metal, carbon and hydrogen. Let's look for nitrogen. Nitrogen is right here. It is also a non-metal. And then I have hydrogen again, and we already looked at that one. I have carbon again, we already looked at that one. Oxygen, oxygen, and hydrogen. So all of these are non-metals. So non-metals bonded with non-metals is a molecular bond compound or covalent. And that is it for the easy part. So with these, you can answer about 4 questions on the exam if you really understand all of this that's happening. Let's move on to the medium. Is lithium a metal or a non-metal? Well, you have to refer to your table here. So lithium is not one of the ones that I highlighted. So lithium is definitely a metal. It is definitely, let me get my orange pen here. Lithium is definitely a metal. Name 3 elements lithium can react with to form an ionic compound. Well, I know that lithium is a metal, and an ionic compound is one that forms or bonds a metal and a non-metal. So if I already have my metal, I need to find my non-metals. And I can choose any of the non-metals that I have highlighted. I can choose fluorine, chlorine, bromine, iodide, selenium, sulfur, oxygen, nitrogen, phosphorus, carbon, hydrogen. You could also choose the noble gases, but they're less reactive. Actually, they are not reactive at all, so it's difficult to have them react with anything. So I'm going to pick any of my non-metals that I have. So I'm going to say, let's see, fluorine, I can do it with chlorine, oxygen, sulfur, nitrogen, phosphorus, carbon. Any non-metal. That's all I need for an ionic compound is a metal and a non-metal. All right. The Roman numerals in an ionic compound represent the charge of the blah, blah, blah. So anything that is within the parentheses and it's like a number 3, or it's a number 1, or it's a number 2, or it's a number 4, any of these represents the charge of my metal. So if you'll notice, for example, down here, I have tin, and then the parentheses with the Roman numerals, and then whatever else is left. These Roman numerals represent the charge of my metal. They represent the charge of my metal. They represent the charge of my metal. And the reason why we need to put these on here is because when we're talking about transition metals, these types of metals can form more than one type of ion. And because they can do this, we need to be very specific with which is the charge. Because if we change the charge, it changes the number of atoms, like by the, how we can tell the number of atoms is by the subscript. It changes the number of atoms that we need to use for that compound. So it is very important to put Roman numerals for transition metals, because transition metals can form more than one type of ion. They can form many. So we have to specify. All right, next. Write the names for the following compounds. Well, I know that Al is aluminum. I know, based on this little picture that we saw earlier, aluminum is not a transition metal, so I do not need to put Roman numerals. And then I have sulfur. And I'm not going to write just sulfur, I'm going to write sulfide. And that is because anytime that I end a compound name, I have to do the IDE, unless we're talking about polyatomic ions, and in case that's different. Okay, so this is aluminum sulfide. Pretty easy. Aluminum is not a transition metal. I do not need to write the Roman numerals. COCl3. So I know that CO is cobalt, and how I'm figuring this out is I'm going into my periodic table and I'm finding the element symbol. So if I need to find CO, I'm going to be like, oh, where is it? Where is it? Oh, there it is. And it says right there, it's cobalt. Very small, but I can see it. All right, so cobalt. Cobalt is within my transition elements, my transition metals. And if you really want to make sure that it is, you look at this one. So cobalt is like 1, 2, 3, 4. It's like right here. So it would be 1, 2, 3, 4. It would be like right here. And that is a blank element, so it is a transition metal. So I know that for cobalt, for this problem, I'm going to need a parentheses of some sort, and I'll figure that out in a bit. And then I have chlorine, and I have 3 atoms of chlorine. I'm not going to write chlorine, I'm going to write chloride, and an IDE. So now I have to figure out this charge. If I have 3 atoms of chlorine, I know that chlorine is a -1 ion element because it is right here in the last, right before last group. So all of these have a -1 charge. And I have 3 right here by the subscript 3 -1 charges. So -1, -2, -3. I know that compounds have to have a total charge of 0. So if I only have 1 cobalt, I only have 1 atom of cobalt, it has to be able to neutralize these 3 negative charges. So my cobalt has to have a charge of 3 positive. 3 positive cancels out with -1, -2, -3. So this should be a 3. My cobalt has a charge of 3. All right, next one. I know that Cu is copper. I know that copper is right here, and it is a part of my transition metals. So it is going to have some kind of Roman numeral. And then SO4, this is a polyatomic ion. It has many atoms in one. And I can find it in my list. Where is SO4? Ah, found it. It's right here. SO4 has a charge of 2-. let me just write the name. So SO4, the name of that is sulfate. So this one I can just straight up write sulfate. The last part is I need to figure out the charge. So SO4 has a charge of 2 minus, of 2 negative right here. And there's only one atom, or one, how do you say this? One polyatomic ion of SO4. And there's only one of copper. So whichever charge this copper is, it has to be able to balance out the charge of my sulfate. And because the charge is 2 negative, the only other charge that can balance it out is 2 positive. So this copper has to have a charge of 2 positive. And I put a 2 in the parentheses. All right, next one. Write the formulas. So now we're kind of switching it. Rather than going from formula to name, we're going from name to formula. So, copper to phosphate. I think it's easier finding the formula from the name because I know that this parenthesis, this Roman numeral, is the charge of my metal. So copper has a charge of 2 positive. Phosphate, I can find it right here. Phosphate is PO4 3 minus, right here. So PO4 3 minus. I have to add atoms until I have these charges canceled out. So let's say that I am going to add another Cu2 positive. So now I have 2 copper atoms, copper ions. I have a 4 plus charge here and I have a 3 minus charge here. So I'm going to add another one of these ones, PO4 3 minus. So now I have a 4 plus charge here and a 6 minus charge here. So let me write that right here, up here. I have a 4 plus charge here and I have a 6 minus charge here. So I need to add a 2 plus charge here to make this a plus 6 so it can cancel out my minus 6. So I need to add another copper atom. So now if I add my charges, I have plus 2, plus 4, plus 6. Now I have a plus 6. And if I add them here, I have a negative 3, negative 4, 5, negative 6, and negative 6. So plus 6 and negative 6 cancel out, and now I'm finally balanced. So in order to balance it, I needed to draw 3 atoms of copper, and I needed 2 atoms of phosphate, or 2 polyatomic ions of phosphate. So I need to draw my parentheses, PO4, and I needed 2. Next one, tin. I know that tin is SN, and I know that tin has a charge of positive 2 because it tells me right here. Fluoride. I know that fluoride refers to fluorine, and how we've already looked at this. My fluorine is in this group, and all of the elements in this group have a charge of negative 1. So I know that F has to have a charge of negative 1. I have a 2 positive charge and I have a negative 1 charge, and I know I have to make both of these cancel each other out, both of the charges. So I'm going to add another negative atom, another fluorine, and now I have a positive 2 charge and I have a negative 1, negative 2 charge. I have a positive 2 and I have a negative 2 that cancels out. So to do this, I needed to do 1 atom of tin and I needed 2 atoms of fluorine. All right, and last one, barium nitride. So barium is in group 2 of my periodic table, so it will have a 2 positive charge. So barium has a 2 positive charge. Nitride, I know, refers to nitrogen, and it ends with IDE, so I know that this refers to nitrogen. Nitrogen is right here. I know that these elements will always have a negative 3 charge. So N, nitrogen, is going to have a negative 3 charge. I have to balance out my charges one more time. So I'm going to add another barium ion, and I have a plus 4, negative 3, still not balanced. I'm going to add another -3 ion. So I have a +4, -6, still not balanced. I'm going to add another barium ion. And now I have +2, +4, +6 total charge here. And I have a -3, -6 total charge here. So now I'm balanced, +6 and -6. And to do this, I needed to have 3 barium ions and 2 nitrogen atoms. And that is the medium portion of the review completed. So now let's move on to the hard stuff, the challenging, not that bad. For each metal, write if it is a transition metal. Oh, let me move to red. Write if it is a transition metal or if it is not. All right, so I'm gonna need my periodic table that I've written all over and this. Vanadium. Vanadium is right here. Vanadium would be probably 1, 2, 3, right here. It is blank. That means that it is a transition metal. I'm gonna do transition metal. Sodium. Sodium is right here. It is in group 1. It is not a part of my transition metals because it is right here. And it always has a charge of +1, so not a transition metal. Not a transition metal. Iron. I know that iron is right here. If I look right here, iron is about right here. This would be where my iron is. It is blank. It is a transition metal. Zinc. Zinc is a tricky one, and you're going to see this twice on your exam, and you have to be able to remember zinc. So zinc is right here. You're like, oh, it's where all of my transition metals are. It's a transition metal. But nope. Zinc always has a charge of +2. It is not a transition metal. Not a transition metal. You will see this on your exam twice. It is not a transition metal. Next you have magnesium. Magnesium is in group 2. It is right here. I could find it on this periodic table right here. It always has a charge of +2. It is not a transition metal. It does not transition between different ions. It is always a +2. Next we got gold. So gold is right here. If we looked on this periodic table, it would be right here. It is blank. It is a transition metal. Oh, I forgot my acronym. Oh well, transition metal. So you are going to have to do this in the test and figure out which metals are transition metals and which ones are not. So they're only transition metals if they are blank in this picture. You will not have this on the exam, by the way. So you have to remember the exceptions. Zinc is the most important one, and aluminum. All right, next, write the formula for calcium sulfate. So I know that calcium has a charge of 2 positive because it is in this group. 2 positive. And sulfate, if we look back into my polyatomic ion sheet, and you will have access to this list, sulfate is SO4 2-. Sulfate is SO4 2-. I can see, oops, sorry. I can see that my charges, 2 positive and 2 negative, cancel out. So this is already ready. Like, I don't need to do anything else because they're already balanced. I just need to write 1 atom of calcium and 1 polyatomic ion of SO4. That's it. Let's move on to maybe a harder one. Maybe. Magnesium sulfate. So I know that magnesium is in group 2. So we'll have a 2 positive charge. My metals always have positive charges. So Mg, let me draw one here. 2 positive. Sulfate, we already saw that it has an SO4 2-. Again, with this one, my 2 positive and my 2 negative already cancel each other out. So I don't need to add any more atoms or polyatomic ions. I can just straight up write the formula. So 1 atom of Mg and 1 polyatomic ion of sulfate. All right. Let's see. Next one, beryllium sulfate. Beryllium again is in group 2, so it has a 2 positive charge. So beryllium has a 2 positive charge, and sulfate again, SO4, 2 minus. Again, you should see that 2 positive and 2 negative cancel each other out, so I don't need to add any more atoms or any more polyatomic ions. So my final formula is Be, and then S1 polyatomic ion of sulfate. That's it. So you should notice a trend here. For all of the group 2 metals that we just used, so calcium, magnesium, beryllium, all of these have a 2 positive charge, and sulfate has a 2 negative charge. So for all of these, I only needed 1 atom of the metal and 1 polyatomic ion for to balance out the equation. So you should see a trend here. And everything that is in the same group should have a similar trend because they have the same ions. All right, next. This one isn't really challenging at all, actually. I just didn't have space, so I put it in here. Circle the subscript. So the subscript is the little number. So this would be that one. The subscript here would be this little 2. The subscript here would be this little 4. And that's it. Pretty easy. All right. How many oxygens are in chlorate? So I'm going to go back to my polyatomic ions, and I need to find the chlorate. Chlorate is right here. Chlorate is ClO3. So chlorate has 3 oxygens. How many oxygens are in chlorite? So chlorite is right here, and it is ClO2. It has 2 oxygen atoms. So what do you notice here? The difference between chlorate and chlorite is that ite has less oxygen. Specifically, 1 less oxygen. So be able to determine just based on the ending of the name, ate versus ite. Ite is smaller, ite has less oxygens. And last but not least, we're almost done here. Write the formulas for iron to chlorate. All right, got it. I know that iron is Fe. I know that the charge on my iron is a 2 plus charge because of this Roman numeral. And I know that chlorate, so look at here, chlorate has a ClO3 minus charge. So ClO3 minus. I look at the charges and I see that they're not balanced. I need to add another negative charge to balance it out. So I'm going to draw another ClO3 minus. Now I have a +2 and a -1, -2 charge. Now I'm balanced. So now I can write the formula. So I used 1 atom of iron, and I used 2 atoms of or 2 polyatomic ions of chlorate. 2. All right, next one, iron 3 phosphate. So I know that iron in this case has a 3 plus charge because my Roman numeral is 3. And phosphate, if I look at my polyatomic ions, phosphate is down here, and it has a PO4 3 minus charge. So PO4 3 minus. If I look at my charges, 3 plus, 3 negative, they cancel out. Super easy. I don't need to do anything else. I can just write my formula. So I used 1 atom of iron and 1 polyatomic ion of phosphate. Boom. Next one, iron to oxide. So I know that iron in this case is going to have a 2 positive charge because of my Roman numeral. And oxide refers to oxygen. And I know from looking at my periodic table, oxygen is in this group, and everything in this group is going to have a 2 minus charge. So oxygen will always, always, always have a 2 minus charge. So oxygen will have a 2 minus charge. I look at my charges, 2 plus, 2 negative, balance out to 0. So that is all I need to do. I just need 1 atom of iron and 1 atom of oxygen, and that is it. So if you can run through this whole review and understand it and do it yourselves, you should do great on this exam.